This problem is about 6 capacitors that are connected in parallel. And the question asks, what is the equivalent capacitance? And then part B says, what is their equivalent capacitance if connected in series? Okay, so we'll start with A. So we're given that our capacitance, they're all the same, so C for each one is going to equal 4.7 microfarads. And we want to find C equivalent. And for B, this is for parallel. Oops. And B is find CEQ for series. So let's start with A, and we'll draw the circuit. So we've got, we're going to do them in parallel. So we've got 1, 2, 3, 4, 5, 6. And these are equal lengths for the capacitor. And then here's my battery. And we're going to go up here, up here. And okay, and so each of those, let's see if I can just erase this little line right there. Yep. Okay, so when we have capacitors in parallel, we know that they add. So we're going to get C is equal to the sum of them for when we have C in parallel. So this is parallel. And that just means we're going to add up all of the capacitance for each one. And so since there's 6 and they're the same, then my CEQ, this is EQ, CEQ is equal to 6 times 4.7 microfarads. And when I do the math, I get CEQ is equal to 28.2 microfarads. And why do we do this? Why do we find the equivalent equivalent capacitance? Well, a lot of times in a circuit when I'm doing calculations, I want to redraw this circuit. So I want to redraw it to be just one capacitor connected to my voltage source. Right, so this is going to be CEQ here, and then I can go ahead and calculate, say, the voltage or the charge or something like that. So there's a lot of times in when we are working with circuits or electrical components that we want to know the equivalent capacitance or the equivalent resistance, so something like that. One thing also to know is that when we find the equivalent resistance, the equations that we use are switched. So if I had a whole bunch of resistors in parallel like this, I wouldn't use the same equation. I would use the equation so this is A, that we're going to use in B. So it's something interesting to note that the equations are switched when we're doing capacitors versus when we're doing resistors. Okay, so for B, in this case, we have them in series. So I'm going to do 1, 2, 3, 4, 5, 6. So these are going to be connected like this. And then these are going to be connected to my voltage source like that. Notice I'm drawing for a voltage source, the long side is the positive side and the short side is the negative side. Okay, so when we find the equivalent resistance for series, we write 1 over CEQ is equal to the sum of 1 over CI. So I'm adding up 1 over CI for each one, and so in this case it's going to be 6 times 1 over C, the C that we have for each one of these. And so that's going to be, let's see, let's move down a little bit. We're going to have 1 over CEQ is equal to 6 over 4.7 microfarads. And then when I flip that, I get CEQ is equal to 0.78 microfarads. And now when I redraw that circuit, I'm going to redraw this to look like one capacitor again. And this is my voltage source. Right, and now this CEQ is going to be 0.78. And so again, we just do this because we want to calculate, say, the charge or the voltage or something like that.